take notes?
Because I find them beautiful.
Oh, well,
Right.
that's another thing. Why don't you take a picture?
I take notes.
Because we write way too fast. You couldn't take it. I would have like 50 I would have like 50 terabytes of images in that class.
Did it work as
Pictures.
perfectly as I wanted it to?
Okay, good.
He can do integration by parts, and he can do it in his head and write it faster than I can just write him writing it.
All right. So, this is intended mostly to scare you and reassure you.
It won't be like last year's final.
Sure, why not?
It won't be like last year's final.
Should have worn a white grim.
What was wrong with last year's final?
I remember walking in the grading and just seeing the scores of F.
Angel is dead.
No, the
For
winner's black.
electromagnetic theory?
Yeah.
Rubber's black.
No,
I thought it was a good letter.
no. Actually, the students in the
Practice
class
for
did
friendship.
fine.
After you scaled at 10 points?
What?
After you scaled at 10 points?
I actually don't remember the I have good recollections. I thought the exam, I actually have last year's exam here, but I'm not going to share it with you.
Is it online?
No.
On LMS.
It's not online. And you're not going to get the same exact one. No. Definitely not. But I can get ideas from it, so.
But that's why we want it.
Yeah, I know. So, I went through the class schedule that I posted for you. See, here's where you could actually save yourself some time. Is if you actually had the thing open on your computer. A document open, and then you could just put like a little plus next to various things as we go along. You know, say, oh, he said this, he said that. That's a good idea.
When was the last time you
Not
uploaded a
stealing my
revised
pen.
schedule?
When was the last time what?
You uploaded a revised schedule. Was it
Never.
one?
He
You know what I'm willing to do, actually, come to think of it, now that everybody's pulling out all their, I would be happy to go through the final revised schedule, which is the one that I have here, and which reflects reality. And you know, put like an asterisk or something like that next to the topics that I feel are important and fair game. But I should tell you that the exam is only going to be between 15 and 20 multiple choice questions with explanation. So you can get partial credit on the multiple choice questions. And actually figure 15. But I leave myself permission to go to 20 if I come up with 20 good ones. And I'm going to think I leave myself a little bit of room, 4 or 5 problems. And there's got to be at least one problem, maybe 2, on the new material. However, the new material, as far as problems are concerned, as far as multiple choice questions, all of the new material is fair, right? But as far as extended working problems are concerned, cavities and waveguides are excluded from problems. But boundary conditions in waveguides, that would be fair. For example, what are the boundary conditions for this or for that? So it's probably easier to go through what's... No, I'll actually sort of start at the top. The first class dealt with essential math, and we used it throughout the rest of the semester. I'm not going to examine you specifically on math. For the final, of course, you are allowed a Shams, and you are allowed... How many sheets of paper?
3.
3 sheets of paper, both sides. So the first thing that we covered was electrostatics, and let's say the two interesting problems as far as, or two interesting types of problems as far as that is concerned, are problems that involve Gauss's law, using it to solve for fields, and actually finding the electric field or potential due to a distribution of charge, having to integrate over the distribution of charge. Then, as far as potential is concerned, I would say that a very important aspect of this course is being able to use Laplace's equation with boundary conditions to find the potential in a certain region of space. Very important for this course. All I said is that it's important. I have 3 classes here on boundary value problems and Laplace's equation. Multipole expansions probably would be a multiple choice question. Yeah, that sort of question, right? Then electric and magnetic fields in matter. What are the what is the meaning of, and utility of permeability and dielectric function, and what are the boundary conditions that apply when you cross from one material to another? There's room for a lot of conceptual problems with respect to relativity. That's where I'm up to now. There is a possibility, if I decide that something that has to do with writing down the electric field and then transforming to find the magnetic field as viewed from a moving frame. As you've had at the least a quiz, a homework, and an exam question on that. Maybe more than one exam question. Yeah.
The multiple choice with explanations.
Yes.
Do you intend for those to be approximately equivalent to the amount of work or time or explanation that it took for the quizzes? No, wait, that doesn't make sense.
I didn't have any multiple choice on any quizzes.
Well, you did have one, but that's not.
Not the multiple choices of the quizzes, but like the amount of time and the amount of work required for several of the quizzes.
What's the
Less work than that for each of these. Like the explanation isn't going to require us to.
No, the explanation is going to be a sentence or two or an equation that just says, I understand what this is about.
Okay.
I
Is
didn't
the way I'm
understand
thinking
it,
about
yes.
it. You're not going to be, writing in a paragraph.
Okay.
If you do, I won't read it. Right?
All right.
Well, maybe I shouldn't tell you this, but when you write something long and involved, I scan through it quickly looking for the buzzwords that are important, symmetry, spherical, and that's it. I don't actually read what you read.
Oh, but it can
Okay.
be important, because if you make a really long explanation and you mark it wrong,
Then,
you can go back and argue, fight for your point.
It's the fine.
Yes, you can.
Yeah.
And
No, but
Brian would if
he
he got a
would
minute.
certainly come back the next semester to
As will I.
I was tempted with OCAP, I must confess.
Would you be able to?
Would you be
But
going
I'm
back
not
to
paying
argue
enough.
with Professor Moore? Is that what you were suggesting?
No, that I would be arguing with Professor Alders.
Oh, okay.
While strict is also
But if we came back to argue with it, would you be able to change our grade if it were next semester?
Sure.
Oh, okay.
I have approximately 2 years to change it.
Cool. Good to
That is not an invitation to come back.
know.
I can actually lower a grade
I know.
if you prove to me that you didn't really understand it.
I know.
Okay. So,
I got it.
you heard me, right?
I got you.
Loud and clear.
Okay. So transformation of field tensor would be, that's where I was, I think. In the schedule, I had a couple of things that I had a discussion of magnetic monopoles. I never made that discussion.
That would be nice.
It's cool, go read it
Graph strings.
after the exam, after the course is over.
Probably.
Yeah, I discussed boundary conditions and permeability, magnetic materials. Then we moved on to time varying fields in general, but we treated that pretty muchly even though the fields were time varying, we treated it in what I would call the static case. That is, that we didn't worry about the propagation time of the fields from one point to another. So it wasn't the full-fledged electrodynamics. And we did quite a bit with that. The current is varying and creates a magnetic field. You have displacement current that creates a magnetic field. I gave you a problem on that, yes.
So that would be all the magnetostatic stuff that I did.
Yeah, electromagnetic statics, yeah, includes oscillating currents.
Well, there was a note in the book that said that the equations were extremely close to correct for household AC circuit or AC current.
Yes.
Which oscillate like 60 times a second.
Yeah. Basically, I think I even discussed it when I got to radiation. That in the limit where the wavelength of the radiation that's being emitted is much, much larger than the system and larger than the distance for observation, then you can treat it in this sort of static limit where you don't pay any attention to the size of the system other than that the field falls off as 1 over r or 1 over r squared, or 1 over r cubed. So, you know, this long wavelength static limit is just fine for solving for the magnetic field with an oscillating current, for example, as long as, you know, we're oscillating at 60 hertz. At 60 hertz, the wavelength of the electromagnetic wave that we would be talking about would be, probably going to get the arithmetic wrong, but I'm going to say of order 10 to the 7th meters. So that's a pretty good approximation to say that it's a static limit.
So we're observing it on Earth.
Yeah, then we're fine. Okay.
That would be approximately
Then I spent a lot of time
Yeah.
on waves, sorry, electromagnetic waves, in vacuum, in materials, and boundary conditions for electromagnetic waves when they reflect off surfaces, for example. And you had a lot of homework problems related to that as well. So I wouldn't be surprised to see something on the final that's related to that. Well, I wouldn't because I know, but you shouldn't be surprised. Yeah, I think I probably spent 3, 4, maybe even 5 classes on wave propagation in various materials, the meaning of the dielectric constant, losses in metals. Yeah, 5 classes, 1, 2, 5. That's a large fraction of the class. And that's all new material that was not previously tested. Radiation by a moving point charge, and the idea of the retarded potential was not previously tested, and we had extensive homework on it. And then there's, you know, the finish up conceptually the idea of cavities and waveguides and what are the allowed modes of a cavity or a waveguide propagation of a waveguide. And I'll put up that list of highlighted things.
Notice on there you didn't include magnetic circuits.
Oh, magnetic circuits,
Oh, okay.
conceptually, right? Turns out that I failed to give you an actual homework problem on magnetic circuits. But, understanding what happens when you insert a gap into magnetic coil, for example, what happens when you change the width of the gap? That's,
Okay, so that's
Fair.
multiple choice questions.
yes. Yeah, I'm not tying myself down too much. I say that. Yeah. I will pretty muchly constrain the longer, I've said this, but I'll say it again. The longer assigned problems will be variations and twists on slightly different ways of working with problems like the homework problems. I'm perfectly fine if I've given you a square, right, to ask you to instead do a rectangle or an octagon. But I have to attempt to make this so that each of the longer problems, because you're going to have 3 hours for the examination, 180 minutes, right? And I have to figure that you need something like 4 minutes per multiple choice. That's much better than the physics graduate record examination, by the way, where you get 1.8 minutes per multiple choice question.
That long?
What?
That long?
Yes, you have that
Feel
one,
like-
1.8 minutes, as long as you're very, very efficient.
1.8 minutes.
It's enough time to read the question and do that, and then move on.
Well, it depends on the type of multiple choice.
Because you have to read it carefully, because people like Professor Napolitano might be the ones who edit the final versions, and they can be sneaky. They think about what kinds of mistakes you might make, and they make sure that that's one of the choices. So if you don't read carefully, then you will completely blow this history. But I'll figure 4 minutes times 15, that's an hour on multiple choice, 2 hours for the rest of the examination, that's half an hour per problem. So I have to make sure that it's a problem that can be done by me in,
5 seconds.
Half an hour?
no. I'd say probably would be fair is if I could do it to my satisfaction in 15 minutes. Then it's fair for me to ask you to do it in half an hour. The ratio, by the way, for Physics 2 is 5 to 1. Of course, I wrote the exam, but I have to be able to do the examination and get above a 95 on it in 12 minutes. Otherwise, it's not an acceptable examination.
You don't edit the multiple choice questions and anticipate the mistakes they'll make and change it.
Oh, yes, we do.
For physics 2?
Yes, we do.
Oh, okay.
Well, with
We're
multiple
kind
choice-
of, look, there's no question, according to Professor Dwyer, that I could write what I consider to be an easy Physics 2 examination,
And nobody would.
and the average would be 30.
Yep.
Because there's always a way to take a problem and just
Fair enough.
twist it just enough so that only the people who really understand it will get it right. And then you put in all of the misleading answers, they're called distractors. All the ones that you know that they're going to do, that they're going to make. So it is possible to totally screw the Physics 2 students. But we don't. We actually aim for an average above 70 and then are shocked, just shocked when the average is 65 or 63.
And then you get people in teens and you just go, are they even
Yeah,
paying
you're
attention?
wondering what they were thinking, what they were doing, why they're still registered for the class. They've just gotten a 13 on the third examination. Was it a 13?
Yeah, it was
On
a
the third
13.
exam, why are they still registered for the class? After
Right.
having gotten, like
You got all the
28,
units right.
28 and 22.
They go-
And they didn't drop.
They got all the points for the units.
Right.
They get on.
Wait a second.
So
That actually would be all, no.
right now, by talking about this, I'm wasting your time, actually.
Yes.
So, I'm going to post this list of topics, sort of a revised with little stars next to the emphasized names, all right? I will put that up.
Go get the homework.
I will get those homeworks that I have. And Wenting actually gave me homework yesterday. She gave me 2 homework. Those are the ones that are at home, actually. I carried them with me to see what was in there, you know, and then I just left them on my kitchen table.
Are those 6 and 10 or those?
I don't remember which ones. I know last night I graded, I probably graded 10. Oh, question, homework 10. I posted the ones that I graded. I haven't posted hers yet. Because she gave me a separate file and I had to modify it and upload it. So it must have been 6 and 10 that I graded, that I brought in with me, and I'll give it to you. Yes.
If we find discrepancies amongst the grade on LMS and the grade on IRA, we would have to.
Do let me know.
All of the grades on LMS are out of the wrong amount of points. I
Yeah.
have an infinity percent homework average at the moment. At least one of them is out of 0.
Yeah, this is because I left the titles of the columns the same because it turns out it's really hard to remove and insert columns in
The
LMS.
same problem is true for all of my other classes. They're all out of
Yeah.
either 0 or something wrong. Or
And you can't go in and edit the out ofs. You have to erase the column and then recreate it in order to
And
change
then
the out
re-put in
ofs.
all-
Professor Whitted seems to have mastered the new LMS.
What?
Professor Whitted seems to have mastered the new LMS. There's no, like, mistakes at all.
Well, good for him.
Yeah.
I'm very happy for him.
But it.
He probably told his grad student to do it.
Yeah.
Probably.
Is that on?
Yes.
All right. I'm not going to say anything now.
Hold on a sec.